Okay, we are now going to learn how to convert from a rectangular coordinate to a polar coordinate. So in this case, we are given just a regular ordered pair, x, y, and what we want to do is we want to convert that to a polar coordinate. We want to find the r and the theta. Okay, so let's just say our xy is over here. That's xy. And what we want then is we want this distance to the pole, we want r, and then we want this theta here, right? And now what you're going to do, when you do these, I would just draw a diagram out, okay? And then you're going to drop this down to the x-axis and make a right triangle. Of course, if it's below, you would be dropping it up to the x-axis. And now what you're going to do is you're going to use the information you have about this right triangle to find r and to find the angle here inside the right triangle. And so basically this ordered pair gives you the two legs. It tells you this is x and this is y. Okay? And so r here is pretty easy because this is the Pythagorean theorem, right? You would have like x squared plus y squared is equal to r squared. Okay, so basically your r is just the square root of x squared plus y squared. So the r is pretty easy there. And now this angle here is what you're going to find. This won't necessarily be the angle that you want because you see we want this angle. But once we know what this angle of the triangle is, then we can easily find that angle, right? And so basically we have the opposite over adjacent. So we got like the tangent of theta is equal to y over x. And so our theta is the tangent inverse of y over x. But this theta is the theta in your triangle. So this then needs to be adjusted to the, we'll say, actual theta. Oh, I should say actual. I shouldn't have spelled out theta there, but that's okay. Let me just say the actual angle that you're looking for. So let's actually do one here. And let's do one that's over in this quadrant down here, if we can do that here. So let's say we have like -8 and we'll say 5. Okay? So basically you got this thing here. -8 is like way over here, and then 5 would be up here somewhere. And so we have this ordered pair. And we want to get the r here, and then we're gonna want to get this theta. Okay, so we'll drop this down, and then this side of the triangle is 8, and this side is 5. And I don't worry about the negatives or anything. So my r is just the square root of 5 squared plus 8 squared. Okay, so this would be 25 plus 64. So that would be, I'm going to need the calculator anyway. So 25 plus 64 is like 89. So the square root of 89. That would be the exact answer, but if I want it as a decimal approximation, it'd be like approximately 9.4. So that would be my r. And so now the tangent of theta would be 5 over 8. Okay, the opposite, I'm going to get this theta. This is like the theta here that I'm going to get, the theta of the triangle. And so that theta, and we could even let's call this theta, and we call this theta with a little apostrophe there. And so this is going to be the tangent inverse of 5 over 8. And I'm going to, I got this in radians here. So that's like 0.56. I'll round it to 2. So that's like 0.56 radians. So that's actually this angle. So this is 0.56, right? And so what I'm going to do, this whole thing is pi, and I'm going to back it up by that 0.56. So I'm going to take pi minus 0.56, and I get 2.58 for my, and that'll be my angle in terms of radians, okay? And so my final ordered pair, my final polar coordinate is going to be 9.4 and 2.58. Okay, so and this is a radian. This is r here, and this is a radian. My theta in terms of radians. So this angle is 2.58. Okay, so sometimes this is more clear if it's degrees, because then this clearly is an angle. Okay, this almost looks like a polar, like a rectangular coordinate. So you got to know that this is a polar coordinate and this is in terms of radians. Okay, so let's try another one now. We'll try one more. And so, I don't know, we'll say negative 158 and 200 and, or we'll say negative 275 for my y. Okay, so let's draw nice big, both of these are negatives here, so maybe I'll do like this. And we'll say this is negative 50, negative 100, negative 150, oh, negative 200, I guess I gotta keep going. Negative 250, negative 275. Okay, and this is negative 50, negative 100, negative 150. And so my rectangular coordinate here is going to be, this is 275, and this is like a little past 150. Right? So this is negative 158, negative 275. And that's my rectangular coordinate. And so what we want is this r, right? And we are going to, we're going to want this theta here, right? We're going to want that theta. Okay? So what, I'll let this angle here be my theta prime. Okay? And then this big long side is 275 and this side is 158. I'm going to just ignore the negatives here. And so that's why I would draw the triangle out. And so now I get 158 squared plus 275 squared. I'm going to take the square root of that. So 158 squared plus 275 squared. Take the square root of that, and that is like 317. We'll just round to the nearest whole, 317 approximately. So that's what this r is, 317. And then my tangent of the theta prime, okay, is the opposite, so it'd be 275 over the adjacent 158. So my theta prime is tangent inverse 275 over 158. Okay, so we're going to do tangent inverse 275 divided by 158. And then I'm going to get approximately 1.04. So that is this angle here, and so this whole thing is pi, and then I want to add that to it. So for this one, I'm going to take pi plus this angle, 1.04. So pi plus 1.04 gives me approximately 4.18. And so this would be my angle, okay, and this would be my R. So I would get 317, 4.18. And that would be the polar coordinate. Okay, so that's converting from the polar coordinate from the rectangular coordinate into the polar coordinate. So in the next video, we're going to learn how to convert polar equations into rectangular equations and rectangular equations into polar equations. We're going to do a bunch of that. And graphing. We're going to learn how to graph polar equations.